What today we're going to do is we're going to look at derivatives of expressions that aren't functions. That's what we've been studying up to this point, is derivative of functions. So what happens when it can't be written as a function? So like what happens when we can't write it as y equals an equation, right? So here's the first question. Okay, find the slope of the tangent at x equals 3. So here's the problem with these. This is not a function because it doesn't pass the vertical line test, all right? For every x, there's more than one y, okay? And so, or I shouldn't say that. For some x's, there's more than one y, all right? So right here, we could draw a tangent. So the tangent line would look something like, about like that. So that could be the tangent, but we could also have a tangent down here, all right? So now what's gonna happen is the derivatives aren't just determined by the x, but you also need to know the y in order to know which specific one we're gonna look at, okay? So we're gonna go back and we're gonna talk, and that we're gonna do this problem later on, and we're gonna actually calculate like what's the slope at this one or this one, all right? So back to this derivative notation, okay, that we need to talk about. All right, so if you take the derivative with respect to x of something will always look like this, okay? So I want to look at two different derivatives to help us understand, and we had to wait till this because we actually need the chain rule for this, okay? So if I want to take the derivative with respect to x of, let's say, y, okay? Remember, this is really y to the first power, right? So we can apply the chain rule. So the chain rule would tell us, okay, it's going to be 1 times y to the, and I'm going to need to subtract 1, so to the 0, okay? But then the inside of that power is the y, and we need to take the derivative with respect to x. So what that becomes is dy over dx. So y to the 0 is 1, so this would be 1 times dy over dx. So this turns out to be just simply dy over dx. So the derivative with respect to x of y is just dy over dx. All right, so now let's take the derivative with respect to x of x. Now again, this is x to the first. So again, the power rule. So this would be 1 times x to the 0 times, and now what's inside this function is x. So we're going to take the derivative of x with respect to x, and that becomes dx over dx. Well, the numerator and denominator match, right? So that makes 1, and this is 1, so this is equal to 1. So the derivative with respect to x of y is dy over dx, but the derivative with respect to x of x is just plain old 1, okay? So let's talk about how that looks and how it manifests itself, okay? So I'm going to slide this up now. So we want to take the derivative with respect to x of x cubed. So this is going to be the power rule. So this would be the power down, so that'd be 3 times x, subtract 1 from the power, so that'd be 2. Now, the inside function is x, and so we're going to take the derivative of x, so dx, with respect to x, and that's what it would be, okay? So dx over dx would be 1. So this turns out to be just plain old 3x squared. So everything we were taking the derivative up to this point was of x, something we could write with x. Okay, so now again the y's are going to creep in now. Okay, so this is very similar to the last problem. Okay, because I want to take the derivative with respect to x of y cubed. All right, so that's, I'm going to apply the power rule. So that'd be 3 times y to the second power. But now the inside function is y, but I want to take the derivative with respect to x. So that becomes times dy over dx. And all that is the chain rule, okay? And so what does this come out to be? Well, this turns out to be 3y squared dy over dx. And that's the derivative of y cubed. All right, let's do this last one here. Okay, so the derivative, I cannot say derivative this year for, I don't know why. The derivative with respect to x of x plus 3y. Okay, so this would be a power of 1 right here, and this would also be a power of 1. Okay, so bring the power down, so that'd be 1 times x to the 0 power, and then times the derivative of the inside, which is x with respect to x, so that becomes dx over dx, and then plus, and then 3 times, and then we got to apply the power rule to y to the first, so that'd be 1 times y to the 0 power times, and now we're going to apply the chain rule. So we got to take the derivative of y with respect to x, and that becomes dy over dx. So this would be 1 times 1 times 1. So this whole thing becomes 1 plus, and this would be 3 times 1 times 1. So that'd be 3 dy over dx. And that's how you do it, guys. We just have to recall that the derivative with respect to x of y is dy over dx, and the derivative with respect to x of x is dx over dx, which is really just 1. Okay, so this one's 1, but this one isn't, because they don't, the numerator and denominator make 1. All right, let's go to our next big example. So this time we want to take the derivative with respect to x of x cubed plus y cubed. So this would equal, and we got to apply the power rule along with the chain rule here. This would be 3x squared times, and we need to take the derivative of x with respect to x. So that'd be dx over dx, and then plus, and then this one would be 3y squared times dy over dx. All right, so this makes a 1 right here. So this is just 3x squared. So this is equal to 3x squared plus 3y squared dy over dx. So right now, okay, until we really thoroughly understand this, I need you to be writing the dx over dx. Even though you might in your head might realize, oh, that's just 1, so I don't need to write it. Write it right now, because it's going to help us later on, okay? So just take the time, okay? All right, let's do this next example. So for this next example, we have a product. First time this has happened, okay? So we have x times y squared. All right, so what we have to do is we have to apply the product rule. So it's going to be the derivative of the first piece, which is x. So that would be 1 times x to the 0 power, that's just the power rule, and then times the derivative of x with respect to x, which is dx over dx. And that's the derivative of the first, times y squared, and then plus the first, which is x, times, now we got to take the derivative of the y squared. So that'd be 2y to the first times, and now we got to take the derivative with respect to x of this inside piece, which is dy over dx. Okay, so this is 1, this is 1, this is 1. So this is 1 times y squared. So that's just y squared. If you're going to skip a step, that's what I would do. Okay, when you see this, as long as you're writing this, I'm good, okay? And then this piece right here would be x times 2 times y. And I'm going to write that as plus 2xy, and then times dy over dx. And that's the derivative. Okay, so let's go to the next one. So when you have an equation, all right, we've just been having expressions, okay? But when you have an equation, how do you find dy over dx? So this is how you go about doing it. You got to take the derivative with respect to x, and whatever you do to one side, you have to do to the other side. It's just like solving an equation, okay? To keep it balanced, whatever you do to one side, do to the other side. So we're going to take the derivative with respect to x of this left-hand side, which is y squared, equals, and we're going to take the same derivative with respect to x of the right-hand side, which is x. And so the derivative with respect to x of y squared, that's just the power rule and the chain rule. So this becomes 2y to the first times, and then the derivative of y with respect to x, which is dy over dx, is equal to, and here the power rule would give us 1 times x to the 0 times the derivative of this x with respect to x, which would be dx over dx. So cleaning this up, this would be 2y dy over dx, 2y times dy over dx is equal to, and this would be 1 times 1 times 1, so this is 1. All right. And so how do you find what dy over dx is? Okay. So what you have to do is get dy over dx by itself. We're multiplying dy over dx by 2y. So to undo that, we're going to divide both sides by 2y. So dy over dx is equal to 1 over 2y. Okay. And so here, this derivative, okay, y squared is equal to x, the derivative isn't determined by x at all. All we need to know to find this derivative, the tangent slope, is to know the y coordinate. And that's what this is, all dependent upon the y coordinate. Where some of them are dependent upon the x, some of them are dependent upon the y. All right. And up to this point, they were all dependent upon what the x value was. Okay. So for this next problem, again, we have an equation and we want to find dy over dx. Okay, so there's a sum, a difference, another difference, and it's equal to this constant. Okay, so in order to take the derivative, all right, with respect to x, we need to do this to both sides. So dx of, and we're going to do y cubed plus y squared minus 5y minus x squared, and I'm going to close my bracket, and then this is equal to the derivative with respect to x of the number -4. Okay, so we're going to have to apply the power rule to this. Okay, so this would be 3y squared times, and the derivative of this y with respect to x. So dy over dx plus 2 times y to the first times, and again, the derivative of the inside function with respect to x, which becomes dy over dx, and then minus 5 times, and then 1 times y to the 0 times the derivative of this inside function, which is dy over dx, and then minus, and this becomes 2x to the first times now the derivative of the inside with respect to x, which would be dx over dx, and that's equal to, and the derivative of a constant is always just 0. Okay, so I'm going to clean this up a little bit. Okay, so this is 3y squared dy over dx. This is plus 2y dy over dx. And this would be minus 5 times 1 times 1 dy, so minus 5 dy over dx. And then this would be minus 2x, and this is just 1, so it's just minus 2x equals 0. All right, so here we go. All right, so I taught you this in a way last year, knowing this would be coming today, okay? So what we have is we're trying to solve for dy over dx. So what we want to do is we want to collect all our dy over dx all on one side. It doesn't matter which side, okay? And then anything that doesn't have a dy over dx, we're going to want to move it to the other side. So we're going to use factoring to get the dy over dx by itself, okay? So this one right here, this minus 2x, does not have a dy over dx involved in it. So I'm going to move it to the other side, okay? So we have 3y squared dy over dx plus 2y dy over dx minus 5 dy over dx is equal to, and when I move that over to the other side, it becomes 2x. Okay, so what does this allow me to do? Why did I do that? Okay, this allows me, because each of these terms has dy over dx in it, it's going to allow me to factor it out of all three. And so I'll have dy over dx times 3y squared plus 2y minus 5, close the parenthesis, equal to 2x. And so you notice we had three dy over dx terms, right? But now we have a product. So to get the dy over dx by itself, because I'm multiplying dy over dx by 3y squared plus 2y minus 5, all I have to do is divide both sides by this, and I'll have what dy over dx is. So dy over dx winds up being 2x over 3y squared plus 2y minus 5. Okay. Now, if you decide sometimes, if you decide to move things to the opposite side of what I did, then what's going to happen is the numerator and the denominator will all have opposite signs. So if you move stuff differently, like you moved all your dy over dx's over here to the right-hand side and kept this negative 2x on the left-hand side, okay, the only difference is this would be a negative 2x, and then this would be negative 3y squared minus 2y, and this would be plus 5. So just realize, like if you look at the solutions and yours is opposite, you may have the right answer, okay? The only thing is that if the numerator and denominator are both opposites, okay, then if they're opposite of what I have, then you're probably good. All right. All right, let's go to the next problem. So this is actually the problem that we started the whole lesson with today. All right, x squared plus y squared equals 25 is a circle, okay, with radius 5, and that's what we had the graph of on the very first page. Okay, so now remember I said what's the tangent slope at x equals 3? Okay, now I'm telling you we need to know what the y coordinate is. So I'm giving you not just at x equals 3, but at the point 3 comma negative 4. Okay, so to find the slope, I need to take the derivative with respect to x of both sides. So I'm going to take the derivative with respect to x of x squared plus y squared is equal to the derivative with respect to x of 25. So this is going to be 2x to the first times the derivative of the inside, which is x with respect to x. So that'd be dx over dx. And then plus, and then 2y to the first, and then times the derivative of the inside, which is y with respect to x. So that'd be times dy over dx. And the derivative with respect to x of 25 is just 0. Okay? So this is going to be 2x plus 2y dy over dx is equal to 0. Okay, so this is the only term with dy over dx, so this doesn't have a dy over dx, so I'm going to move it to the other side. So 2y times dy over dx is equal to negative 2x, and then I'm just going to divide both sides by 2y. So dy over dx is equal to negative 2x over 2y. 2's would cancel there, and I'd have dy over dx is equal to negative x over y. Okay, so that's how you do it. Okay, now we're not done yet. Okay, and I'm going to introduce you. You may have seen it. I think I have it on last night's homework. Is I used a notation to say I'm putting this in. Okay, so I want to show you this. This is new notation. So dy over dx. You may have already seen it. Okay, and so when I do a vertical line like this, okay, I'm saying at. That symbol means at. So the derivative of y with respect to x at, and we want to do 3 comma negative 4. And so you can, if it's just at an x value, you can just write x equals. But if it's at a point, you can just write the point 3 comma negative 4. And that's how we write this. Okay. And so this would be equivalent to negative of your x, which is 3, over your y, which is negative 4. So that's just negative 3 over negative 4, or 3/4. So the slope at that point 3 comma negative 4 was positive 3/4. So I'm going to go back and I'm going to take a look at that and show you that it does truly make sense for that to be the answer. Okay, so let me get back to it a few pages. Okay, so this was at the point 3 comma negative 4. See, that has a positive slope, right? And it's almost like at a 45-degree angle, okay? And it's not dead on right because I just drew this, okay? But that looks like it could have a slope of 3/4 because that slope is almost 1, right? And this slope is almost 1 too. All right. Okay, so let's go to the next page. So this is example 9, okay? And I want to find where the slope of 2y is equal to x squared plus sine y is defined, okay? So to know where it's defined, I have to figure out where it's undefined, okay? So let's go ahead and let's take the derivative, okay? So I'm saying slope, so that means derivative, okay? Find where the slope is defined. I'm going to do it where it's undefined, because if I find where it's undefined, then everywhere else it'd be defined, okay? It's kind of weird to say that. All right, so I'm going to take the derivative with respect to x of both sides. So d dx of 2y is equal to the derivative with respect to x of x squared plus sine of y. Okay, so the derivative of 2y, okay, would be 2 times y, well, 2 times 1 times y to the 0 times, now that was just the chain rule, okay? And the derivative of the inside, which is y with respect to x, is dy over dx is equal to, and then this one would be 2 times, or 2x to the first times the derivative of x with respect to x, which would be dx over dx, and then plus the derivative of sine of y. Well, sine of y, the derivative would be cosine of y times the derivative of the inside with respect to x, so that'd be dy over dx. Okay, so this would be 2 dy over dx. I'm just cleaning this up before I start moving stuff. And this would be just 2x. And this would be plus cosine of y times dy over dx. Okay, so you have some choices. Since this 2x is on the right hand side, I'm just going to move the cosine y dy over dx over to the other side. So then I have 2 dy over dx, and then it'd be minus cosine of y times dy over dx is equal to 2x. Okay, so I collected all my dy over dx terms on one side. So now I'm going to factor the dy over dx out. So I get dy over dx, and then times 2 minus cosine of y is equal to 2x. And so since I'm multiplying dy over dx by the quantity 2 minus cosine y, I'm going to divide both sides by it. So dy over dx is equal to 2x over 2 minus cosine of y. Okay, so now let's talk about, okay, I want to figure out where it's defined, okay, where this derivative is defined. So what values can I put into this, okay? So the problem with this is when the denominator, this denominator is 0, okay? So we can't let that be 0, okay? So 2 minus cosine of y cannot be 0. That's really the only restriction on this, okay? So if we can figure this out, all right, we're going to be able to determine, okay, these are the, and it's going to be y values, okay? So for these y values, we can't use those because it makes it undefined, all right? So right now, if we move this over, it becomes cosine y. So 2 cannot be cosine of y, all right? Now, we got to think, okay, the best way to think about this is, and it hurts because you guys weren't around last spring, okay? We got to think of what the graph of cosine y looks like, okay? Or even just cosine of x, because you can think of this as being x, all right? So if you think about this, okay, cosine starts right here at 1 and goes down. So this point right here is 0, 1, and it goes down and then back up, and this would be at 2 pi, 1. And down here, how low does this go? Well, this would be at pi, -1. Okay, so sorry, you couldn't see that. Okay, and then this just keeps going up and down, up and down, up and down. That's what the cosine graph looks like. Okay, and okay, this is weird, but this would be my y-axis, and this would be my x-axis. Okay, so All right, what y values do we put in this where we get out a number bigger than 2? Well, guess what? You never are, right? You never are. So there's no solution to this because cosine oscillates between -1 and 1. It will never reach 2, okay? Not just plain cosine y. If you stretched it, yes, but we didn't stretch it. It's just plain old cosine, okay? So there's no solution, okay? Because cosine y is always between, the output for this is between -1 and 1, okay? And we say inclusive, which means they can actually equal those. So that means when we go to solve this, there's no solution. So there's no solution. So there's no y values that make this true. If there's no y values that make this true, that means there's no y values that makes this derivative undefined. And that was the only thing we had to worry about, right? So what the heck? What does this mean? Okay, well, we couldn't find a y that causes this to be 0. So if we can't find a y that causes this to be 0, what that means is it's defined for all x and y values, okay? So dy over dx is defined, which that's the slope. I should say that. So the slope is defined for all values of x and y. You can put any x in here, and you can put any y in here, and you will have a slope. All right, that's what that's saying, okay? And it's because we couldn't solve this denominator. We can't make that be 0. It's impossible, okay? All right, guys, let's go to the next problem. I promise the next one will be easier. So for this next problem, if 2xy is equal to pi sine y is equal to 2 pi, find the lines that are tangent and be normal at the point 1 comma pi over 2. So here's my point, right? And I basically, when they say find the lines, you want to find the equations of the tangent line and the normal line. So we're going to need to know the slope of the tangent line. From that, we can get the slope of the normal line. And then we have our point, and then we can write our equation, okay? All right, so here's a function with x and y, okay? And what we need to do is take the derivative. I think I just said function. It's not necessarily a function, okay? So d dx of, I was kind of writing that funny, sorry. All right, 2xy plus pi sine of y is equal to d dx of 2 pi. This is going to allow me to get the dy over dx, okay? So right here, this is a product. Now, I would look at this as a product of 2x being the first function and y being the second function, okay? So this would be 2, and then this would be dx over dx. Okay, so this would be 2 times 1x to the 0 times dx over dx. Let me go ahead and write that. Okay, so 1x to the 0 dx over dx. Problem is, you start doing these in your head once you get good at this, and that's what I was just doing. It's like, I shouldn't do that to you guys. Okay, times the second one, which is y, and then plus, and then 2x, and now I got to take the derivative of y, so that would be 1 y to the 0, and then dy over dx. Okay, so that's the product rule for just this, and then plus pi times, okay, now I got to take the derivative of sine, which is cosine of y, and then times the derivative with respect to x of this inside, so that would give me dy over dx, and then that's equal to the derivative with respect to x of just 2 pi. Now, 2 pi is a number. It's just a constant, right? So that means this derivative is 0. Okay, cleaning this up, this would be 2 times 1 times 1 times 1, or this just becomes 2y. If you wrote this as 2 times dx over dx times y, I'd be happy, okay? And then over here, this would be 2x times 1 times dy over dx, so that's just 2x dy over dx, so plus 2x dy over dx plus pi cosine of y times dy over dx is equal to 0. Now what I'm going to do is I'm going to move this 2y because it doesn't have a dy over dx associated with it. I'm going to move it to the other side. You want to move the fewest things, I would think, okay? So 2x dy over dx plus pi cosine of y dy over dx, and this is equal to negative 2y. And that's going to allow me to factor a dy over dx out of both of these. So dy over dx times 2x plus pi cosine of y, and that's equal to negative 2y. So that means dy over dx is equal to negative 2y over 2x plus pi cosine of y. All right. So now to find the equation of the tangent line, okay, we have a point, and that point is 1 comma pi over 2. And we have a derivative, right, which would give us the slope, so dy over dx. And this derivative is dependent upon what the x coordinate is and also the y coordinate. So that we're going to put at, and then 1 comma pi over 2. And then this is equal to negative 2 times your y, which is pi over 2, over, and then this would be 2 times x, so 2 times 1, plus pi cosine of y, which is pi over 2. Okay, so this top becomes negative pi over the bottom or denominator becomes 2 plus pi. And then we got to figure out cosine of pi over 2. Well, pi over 2 is right here. Okay, so because it lands on one of the axes, we're going to let our x be 0, or y be 1, because that's coordinates, and then r equals 1. And that's angle pi over 2. And so cosine would be x over r. So this would be plus 0, or plus pi times 0. So this becomes negative pi over, and this just becomes 2. All right, so my equation of my tangent line, okay, would be y is equal to my slope, which is negative pi over 2 times x minus 1, and then plus, because we want to shift it up to go through that point, pi over 2. And then b, our normal line, we're ready to rock and roll with that one. So our normal line, that would be, okay, so we have to take this slope that we got with the tangent line, flip it, and change the signs. So this becomes positive 2 over pi. So we have y is equal to, and I should say m, I used to say this, m perpendicular is 2 over pi. So 2 over pi times x minus 1, and then plus pi over 2. And I just realized you can't see any of that. Sorry. All right. I'm not going to record that. Sorry, guys. All right. So normal line would be y is equal to, okay, so this is just the symbol for perpendicular. Normal lines means perpendicular, and perpendicular slopes, recall, are opposite reciprocals. So this one's negative, this one's positive, and the reciprocal is just the flip of it, okay? And so that slope, that only thing difference between these are the slopes, right? Okay, and that's it. Welcome to implicit differentiation, guys. Woo-hoo. All right. All right. You guys have a great day, and I will see you.